Hi, my name is Robert Ebelher, and today I'm going to be talking to you about requirements engineering for retrofittable subsea equipment. Today we're going to be talking about the background of this equipment on vessels, why the research is important, some of the challenges with developing the requirements, some of the requirements decomposition allocation philosophy, the functional analysis, the industry standards tracing, the summary of the evaluation results, and how the proposed method can be improved. So a little bit of the background for this. So deep water vessels are complex systems of systems. And two of the main components of what these vessels are used for are mainly drilling and subsea construction. And there's a large variety of things these systems can actually do, and some of them are lower and lift equipment to the seabed. A lot of these systems are remotely operated, and a lot of these systems also have systems which permanently monitor them from the sea level. A big part of these systems, they have to be interchangeable. They have to be able to take upgrades, minor and major modifications, and because they're going to be used on many different vessels. So they also have to be able to be completely replaced by a new system. With new technology coming out, there's always the option of that. So why this research is important. So subsea technology is advancing every single day. Technology in this world right now, everything, it's just advancing like crazy. So for the subsea equipment, there's requirements that need to meet certain criteria, such as safety standards, efficiency, industry standards, and the customer requirements for sure. Also, this model-based systems engineering framework is going to require some tailoring to do this, and the requirement gathering and requirement analysis is also important. So what are some of the challenges with developing requirements for subsea equipment? So the main challenge to start out with is determining the scope, basically. So, with all these different vessels you have to be able to interchange these equipment between these vessels. So, and there's numerous amounts of vessels that you have to change them between, which brings up, the vessel-specific requirements. Another challenge is obtaining access to specific information for vessels. You can have certain vessel manuals, but you have to make sure that these manuals match the actual physical vessel. And then there's the case, well, if you don't have the documentation, well, you're gonna have to reverse engineer it somehow. So those are a couple challenges for that. And the last challenge is assessing compliance with various regulatory and industry standards, which is a big thing, because you have vessels that are located all throughout the world, and you have the requirements that conflict, functional and performance requirements are conflicting. So the requirements decomposition allocation philosophy. So on the left here, you can see that we have the initial partitions, which were came sought after at the beginning of this research. So we have system, segment, subsystem, assembly, subassembly, and part. And on the right, we have the final partitions after a little bit of a trial and error. These were found to be more ideal. So on the left, you see we have system is still the topmost. But you can see these arrows going from segment and subsystem to the actual system. And what this basically means is the segment and subsystems had so few requirements in them that it was much easier to just go ahead and merge them with the system level requirements. So that we don't have all these different partitions going on. We just make it a little bit easier for everyone. So, and also since there's so many different vessels, you also have to have vessel-specific requirements, which is located under the system requirements. And the assembly and subassembly and part, those were all the same with the final iteration. So the functional analysis. So there's 5 stages to this. Stage 1 is basically extracting the functionality from the existing offshore operational manuals. And what this basically is coming up with the initial set of operation scenarios and functional requirements. Stage 2 is interviewing with industry experts. What this basically means is, verifying that the initial set of operational scenarios and functional requirements are good with all the stakeholders and all the system end users. Stage 3, develop the operational context and functional requirements. This is basically taking everything from stage 1 and stage 2 and developing a high level of data from it, taking the feedback from stage 2 and taking the initial set of requirements that were developed in stage 1. And stage 4 is basically refining these requirements from stage 3 and making them, decomposing them into a more architectural system level. And the final stage is basically just an audit on the operational scenarios and functional requirements to make sure everything is good to go, that the requirements match what the actual functionality is. So the industry standards tracing. This is basically an independent line-by-line review by 3 reviewers. And what this means is you basically, 3 reviewers will independently review the requirements, and they will actually match each industry standard clause to one of the following, as you can see below. Conformance with requirement, case for equivalence, missing requirements, or not applicable to design or out of scope. And what this basically means is that these 3 reviewers will all go through each line of the requirements, line by line, and determine, one of these, match the clause up to one of these. And what will happen after the review is, they'll get together, they'll compare the results. If their results are, one person picks conformance with the requirement and the other 2 pick case for equivalence, well, there's a difference. So what will happen is they'll either have to go to a subject matter expert to get some more details, or they'll have to somehow come to an agreement, a consolidated response, basically. And if they all pick the same thing, well, then you have a consolidated response, and basically they will either propose, a change for the requirements or the architecture, basically add new requirements, or maybe modify something or remove something. And this is all captured using the model-based systems engineering, the MBSE. So the summary of the evaluation results. So this is basically what I've been talking about is the application and the tailoring of the model-based systems engineering. And some of the advantages of this is requirement allocation, requirement decomposition, functional analysis, and the tracing of the industry standards, like we looked at previously, to the requirements. Which, like I said before, the tracing of the industry standards, that's a very tedious process. And it's pretty time consuming in itself because you have 3 people looking line by line. So, that could be pretty time consuming. And some of the challenges for this approach is, enforcing the model-based systems engineering across all the boards, basically. And the problem with that is you have such a diverse and global team that, work gets, duplicated, and work also becomes out of date because of the momentum of the project. So how can the proposed method be improved? So see, here's some of my recommendations that this research can be improved. So I think that some more tailoring can be done to the model-based systems engineering. One recommendation is to find some common ground across the board. If that doesn't work, you can also do the MBSE tailoring for different areas to try to reduce the amount of duplicated work and such. Also, I recommend using a configuration management system to log all these requirements documents that are being created by these various team members all across the world, and this can also help reduce the duplication of work, make things more up to date, so that you're always pulling the most up to date requirements documents. Changes are always tracked, and you have the approval / denial of a document, so that people can approve and deny whether the requirements look good or not. The higher level management, and that's all I have. Thank you.